Welcome to Creata classes. In this lecture, we will cover the summary of angle bisectors, incircles and excircles. We will cover all the formulas and fundamentals. Note that no proof will be covered in this summary, okay? Only the formulas and the fundamentals will be covered. This lecture will help you connect all the fundamentals of the angle bisectors. This lecture will also act as a quick reference guide or a quick revision guide just before the exam or few days before the exam. Let's begin with the lecture. First of all, we will start with the introduction to the angle bisector. Let's take a triangle ABC. Angle bisector is a line segment which divides the angle into two equal portions. Here AD is the angle bisector for angle A. AD is dividing the angle A into two equal portions. A triangle is having 3 vertex and 3 sides, so we can have total 3 angle bisectors. BE is the angle bisector of angle B. Okay, BE is dividing the angle B into two equal portions. Similarly, CF is the angle bisector of angle C. So a triangle can have 3 angle bisectors: AD, BE and CF. These angle bisectors have a special property that these 3 angle bisectors intersect at a common point. Here for this figure, the intersection point of 3 angle bisectors is I. I is known as incenter. If we compare the angle bisectors with the median is a line segment that divides the opposite side into two equal portions, while the angle bisector divides the angle into two equal portions. The intersection point of 3 median is the centroid, which is denoted by G, and the intersection point of 3 angle bisectors is I, that is incenter. Moving further, next fundamental is angle bisector theorem. As per this theorem, an angle bisector of an angle of a triangle divides the opposite side in two segments that are proportional to the other two sides of the triangle. Means for this triangle ABC, AD is the angle bisector. The angle bisector AD is dividing the side BC into two portions, that is BD and DC. The ratio of BD and DC will be equal to the ratio of the two sides containing the angle. Here angle A is containing the side A and side B. So we can say the ratio of BD is to DC is A is to B. This is angle bisector theorem. For example, if we take a triangle with AD as the angle bisector, the two sides of the triangle, that is AB and AC, are given as 10 cm and 1 cm respectively. So the ratio of BD is to DC will also be equal to 10:1. This is the fundamental of angle bisector theorem. The ratio of the segments which are divided by the angle bisectors is equal to the two sides containing the angle. Got it? This is angle bisector theorem. Moving further, the next fundamental is the incenter divide the angle bisector into some ratio. That ratio is equal to the sum of two sides containing the angle, that is C plus B, is to the third side, that is A. Which means AI is to ID, that is the incenter is dividing the angle bisector AD. So AI is to ID is equal to C plus B is to A. In this fundamental, the incenter is dividing the angle bisector into two parts. We can compare this fundamental of angle bisector with the fundamental of the median, where the centroid is dividing the median into the ratio of 2:1. In the median, the centroid is dividing the median into 2:1. Here in the angle bisector, the incenter is dividing the angle bisector into C plus B is to A ratio. Side by side we are comparing median with the angle bisector. This will help you better catch the topic. Moving further, now move to the incircles. Let's take a triangle ABC with 3 angle bisectors as AI, BI and CI. These 3 angle bisectors are meeting at point I, that is the incenter. If we draw the 3 perpendiculars from the incenters toward the 3 sides of the triangle, we got ID perpendicular to BC, IE which is perpendicular to AC and IF is perpendicular to AB. These 3 line segments are perpendicular to the 3 sides of the triangle. The concept is that these 3 line segments will be equal to each other. That is ID is equal to IE is equal to IF. These 3 line segments are equal to each other. In other words, we can also say the point I, that is the incenter, is at equidistance from the 3 points, that is D, E and F. Okay, the point E is at same distance from the 3 points D, E and F. Are you able to correlate this with the fundamental of the circle? In the circle, the center is also equidistant from all the points on the circumference of the circle. Similarly, here the point I is equidistant from point D, E and F. So here we can form a circle with point I as the center and ID, IE and IF as the radius of the circle. Point D, E and F will lie on the circumference of the circle. This circle is known as incircle. It is inside the triangle and it is touching the three sides of the triangle. This is incircle, and ID, IE and IF are the radius of the circle. The name given to the radius of incircle is inradius. So this is the inradius. The formula of inradius is the area of the triangle ABC upon the semi-perimeter of the triangle ABC. The area of the triangle ABC is denoted as delta, and S is the semi-perimeter of the triangle ABC. Semi-perimeter means half of the perimeter. If we take the side of the triangle as A, B and C, so the perimeter of the triangle will be A plus B plus C, and the semi-perimeter will be A plus B plus C upon 2. So the inradius, that is the radius of the incircle, is area of the triangle upon the semi-perimeter. This is very important concept. Now we will take a small case of a right angle triangle. Here ABC is a right angle triangle with C as hypotenuse and A and B as the two legs of a right angle triangle ABC. This is a special case, that is inradius for a incircle inside a right angle triangle is equal to A plus B minus C upon 2. Here A and B are the two legs of the triangle. So we can say the incircle of a right angle triangle is equal to sum of legs minus hypotenuse upon 2. This is the formula of inradius in a right angle triangle. This is a special case. Direct questions are asked in the competitive exam related to a incircle of a right angle triangle. So this will help you in directly solving the question. We are not going into the proof of the formulas, we are just covering the fundamentals and the formula, as it is the summary of the complete series. Now moving further to the next fundamental. For this fundamental, again let's take a triangle ABC with AI, BI and CI as the three angle bisectors, and I is the incenter. As per this fundamental, the angle BIC is equal to 90 degree plus half of angle A. This is the formula of angle BIC. This is very simple formula. These are the formulas of incircles. Now moving to the next fundamental, that is X circles. Let's check a triangle ABC. Till now we have covered the internal angle bisectors, the angle bisectors which are inside the triangle. Now we will cover the angle bisector of exterior angle of the triangle. Let's extend the side AB and AC for this triangle. Here these two angles are the exterior angle for this triangle. Let's bisect both of this angle. These two are the exterior angle bisector. These two exterior angle bisector are meeting at a point. Let's give the name to this point as E. This point E is known as X center. Inside it is incenter and outside it is X center. This X center has a property, that is, if we take the angle bisector of angle A, that is the internal angle bisector of angle A, this angle bisector will touch the X center. This is internal angle bisector, so it will be obviously touching the I, that is the incenter. If we further extend this angle bisector, it will touch the point E, that is the X center. In wording, we can say the X center is a point which is formed by meeting two exterior angle bisector and one internal angle bisector. Two exterior angles and one internal angle. Got it? Moving further, just now we have seen that angle BIC is equal to 90 degree plus half of angle A. Now the angle BEC means this exterior angle BEC will be equal to 90 degree minus half of angle A. The angle which is inside the triangle is having the plus symbol, and the angle which is outside the triangle is having the negative symbol. The remembering technique is that internally you should be positive. So inside the triangle the positive symbol will be there, and outside the negative symbol will be there, that is opposite to the positive. Just a small remembering technique. And just one more important fundamental. The angle between the interior angle bisector and the exterior angle bisector means this angle will be 90 degree. The angle between the internal angle bisector and exterior angle bisector will always be 90 degree. Further, with E as a center, we can draw a circle which will touch the three sides of the triangle. One is the main side, that is BC, and two are the extended side, that is extension of side AB and AC. This circle is known as X circle. E is the center point of this circle, that is X center, and the radius of this circle is known as X radius. This is in similar line to the incircle. The circle which is inside the triangle is incircle. The incircle is touching the three sides of the triangle, and X circle is also touching the three sides, but one is the main side and two are the extended side. The center point of incircle is in center. The center point of X circle is X center. The radius of incircle is in radius, and radius of X circle is X radius. In radius is denoted as R. Let's denote the X radius as R1. Let's join the center point E with the three sides of the triangle. Two are the extended side and one is the main side. So these three line segment will be R1. Okay, that is the radius of X circle. Further, are you able to observe these three line segments are tangent to the circle? Tangents are the line which touches the circle only and only at one point. And we know that tangents and radius are at 90 degree to each other. So we can say all these three angles are 90 degree. Further, the formula of in radius, that is radius of incircle, that is R, is equal to the area of the triangle upon the semi-perimeter of the triangle, that is delta by S. And the formula of X radius, that is the radius of X circle, that is R1, is equal to delta upon S minus A. Here delta is the area of the triangle ABC and S is the semi-perimeter of the triangle ABC. This is the formula of X radius. For this triangle ABC, we can have many exterior angles. All these are the exterior angle for this triangle ABC. If we bisect all these exterior angles, we can have total 3 X centers and 3 X circles. These are the 3 X circles that can be formed from the triangle ABC. Okay, got it? That's it for the X circles. So we have done the summary of angle bisectors, incircles and X circles. These all are the formulas that we have covered in the summary. No need to note down the formulas. All these formulas are available in the download section. Go to the download section and download the PDF from the download section. All these formulas will be available there. So that's it for this lecture. Hope you have enjoyed it. Thank you very much for being with Creata classes. Bye for now and best of luck.